Hi everyone, my name is Lim Kai Pei. Today we will discuss unsupervised learning technique. Let's start with the basic. Unsupervised learning can be thought of as a type of machine learning where the algorithm is trained to find a pattern in dataset that do not have any label data. To give you a real-life example, imagine that you have never watched a cricket match in your entire life, but you are invited to a friend's house to watch a match between India and Australia. You have no idea about the rules of cricket, but you decide to join your friend for the match. As the match starts, you feel lost and don't know how to join the game. However, by observing the game, you start learn about cricket on your own. You notice that there are two teams, one wearing blue jersey and other wearing yellow. Since your friends support India and you see the score, you conclude that India has blue jersey while Australia has yellow. You also notice that someone have bat in their hands while others are fielding. You learn that there are around 9 fielders who try to stop the ball from reaching the boundary, and there is someone behind the wicket called the wicket keeper. There are 2 umpires to manage the match, and if the ball hit the wicket or is catched by the fielder, the batsman is out. You notice that there is a player with the number 7 on his jersey, and if he scores a 4 or a 6, you need to cheer. By making this observation, you learn about a basic cricket on your own without any guide. This is a principle that unsupervised learning follows.
Hello everyone, my name is Danilo, and today I'm going to present the importance of unsupervised learning. The primary importance of unsupervised learning is ability to take complex problems that may be difficult or impossible for humans to solve due to capacity limitation or bias. For example, unsupervised learning can be used to explore raw and unknown data, even when the data scientist is not sure what they are looking for. When presented with data, an unsupervised machine can search for similarities between image and group, then into individual cluster, attaching its own label to each group. This type of algorithm behavior is especially useful for segmenting customer, as it can separate data into groups without any form of bias that might be present in human analysis. Furthermore, unsupervised learning algorithm can identify patterns that might not have been previously known, helping to categorize elements and find association between them. In addition, they can be used to detect anomalies and defects in dataset, which can be addressed to improve data quality. And now I will talk about type of unsupervised learning. There are 2 main types of unsupervised learning. The first one is clustering. Clustering involves grouping data points into clusters based on their similarities. The goal is to identify natural group of clusters of similar data points within a dataset. Clustering can be useful for a variety of tasks, including customer segmentation, anomaly detections, and image segmentation. Some examples of clustering algorithms include K-means, hierarchical clustering, and density-based clustering. So the second is dimensionality reduction. This is involved reducing the number of variables or features in a data set while retaining as much information as possible. The goal is to simplify the data and make it more manageable without losing important information. Dimensionality reduction can be useful for tasks such as data visualizations, feature extractions, and anomaly detections. Some examples of dimensionality reduction algorithms include principal components analysis, PCA, TSNE, and autoencoder.
Application of clustering. Clustering can help us in image segmentation to find interesting objects in image to focus on. Besides that, clustering can help for understanding patterns, which can be used to cluster the data based on the various features. For example, clustering is used in applications such as finding credit card fraud detections. Various patterns of the users and their usage of the credit card are studied. If the card is used in the ways that do not match the behavior, an alarm is generated. So this can help to find out if the card is being used by a fraud or not.
What is K-means algorithms? So For the first step, we need to randomly choose k data point. That means any seed can be the initial centroid. Let's say I choose any random 3 seed, and these 3 seed will be the 3 cluster. After that, we'll assign other data point and calculate the other seed distance between the initial seed, like how far. If the point is closer to the centroid, we need to grouping it. And after complete the grouping, you need to recompute the centroid because the point is like increased. So lastly, we will use the convergence criterion to decide the point quality. If the quality is do match, we need to back to the step 2 to do it all again, and until we meet the optimal cluster.
Hierarchical clustering is another unsupervised machine learning algorithm, which is used to group the unlabeled dataset into a cluster, and also known as hierarchical cluster analysis. In this algorithm, we develop the hierarchy of cluster in the form of a tree, and this tree structure is known as the dendrogram. Sometimes, the result of k-means clustering and hierarchical clustering may look similar, but they both differ depending on how they work, as there is no requirement to predetermine the number of clusters as we did in the k-means algorithm. The hierarchical clustering technique has 2 approaches, which is agglomerative and divisive. For the agglomerative is a bottom-up approach in which the algorithm starts by taking all the data points as single cluster and merging them until one cluster is left. For the divisive algorithm is the reverse of the agglomerative algorithm, as it is a top-down approach.